Welcome to the Map Suite Web API Learning Sample on Map Projection. In this video, we're going to show you some of the real basic projections and how you can integrate it in with Map Suite Web API in your application. So let's go ahead and get started. In this sample over here on the left, you'll see we have four different subsections. And with this sample, we're trying to show you some of the common projections and also how you can use rotation and custom projection. So to get started, we'll click on the Web Mercator Projection. This is probably the most popular projection out there, at least for web mapping applications. It's the same one that Google and Bing and all of the popular map providers use. And it's what you would normally see in a wall type, rectangular type map where Greenland's quite large. And this is using a Mercator type of projection. Here on the right, you can see the geography unit of this projection is meters. We also show the EPSG ID, which is a unique ID for a lot of the standard projections out there. And finally, you have your Proj4 string. This becomes important because MapSuite uses Proj4 as its projection library. That's an open source project, and it does a lot of the conversion. It gives us a lot of powerful stuff to be able to use many different projections and even custom projections. The next popular projection is decimal degrees. If we take a look at this, you'll notice that the map is a little bit flatter, but things are more proportionate in size. Even though the polar regions are still stretched and Greenland's quite large, it's not as distorted as the earlier one. This is really nice if you're not concerned with really the look of the map and you just want to stay in your basic WGS 84 longitude and latitude coordinates. Really, then you don't have to worry about doing projection to spherical Mercator and things of that nature. And you can see here, again, the geographic units, decimal degrees, and the SPG number as well. Next, I want to take a look at rotation. With rotation, you can use this for like a navigation system or things where you need to rotate the map. And we've implemented that in MapSuite with a projection in mind. So you can use a pivot center, which is an X and Y coordinate of where you want the map to be centered, and then give it an angle of how you want to rotate. So with this sample, you can take a look at the code and do that. And that's, again, very popular in navigation type of applications where you want to turn the map based upon your heading. Finally, since there are really literally no limit to number of projections out there in the world, there's thousands and thousands of them, and you can even create your own custom projection if you have specific requirements. And that's what this sample's showing you how to do. Basically, you can build up your own, Proj4 string and implement your own projection if you have that requirement within your GIS application. So again, the UI here is very simple, just to show you some basic different types of projections and how the same data can be displayed very differently on the screen. Now let's take a look at the code. So as all of our MapSuite Web API learning samples, you can download the code from Product Center and go to the Code Samples tab and just launch the sample here or view the source code off of our wiki. But once it's downloaded in Visual Studio, we have two projects, one for leaflet, one for open layers. And we'll go ahead and just take a look at the leaflet code. And you can see we've got our default HTML page here, and then we're referencing several different JavaScript files. All of the specific stuff to pretty much this sample is going to be in ThinkGeo JS, although because we are using leaflet and it doesn't have projection support built in, we had to add in some other JavaScript files for Proj4 leaflet JavaScript 2 to do the projection on the client side. So the code here is pretty simple. If you're used to the learning samples, you'll see that it's laid out in a very similar way. And really all we're doing here is when you select that type of projection you want on your left is we're setting the client side JavaScript library to the right projection as well. So one thing you need to keep in mind specifically with the web app or web API is you need to keep your client and your server in sync of what projection you're doing. So this is setting up the client side, and then we're adding that to the map. And here's where we're calling our server side controller to render the tiles in that projection. And this is just a simple switch statement for the different four projections we support in that sample. So let's go take a look at the server side where the actual projection of the data is happening. So it's going to be over here under our controller. And this is where we're exposing our REST web APIs. And when we initialize this controller, we're actually creating a managed for projection class, which is the API within MapSuite. And we're setting our internal projection and external projection strings. So your internal projection is going to need to match what your raw data is in. So I believe here we're using the country shapefile, which is just going to be in straight WGS 84 decimal degree, and we want to convert it to the spherical Mercator web Mercator projection that's we show in the sample here. So we're doing this on the initialization of the controller, so it's ready for us when we go to render the tiles a little bit on later. And this one is doing the same thing, but just for the custom projection that we set up. All right, here you can see is our web API for loading the countries layer. So that's what Leaflet is calling through web API, and we're passing in geography unit, whether it be meters or decimal degrees. And we're loading our shapefile. Setting up our styles accordingly, that green outline you're seeing. And then here we check to see if the geography unit is actually Mercator. We're going to have to do the projection because by default our data is in decimal degrees, WG64, so we only need to project it if in fact we chose Mercator as our geographic unit. So the way we do that is we just set the projection property off of the feature source on the layer to the projection library we created up here on the initialization. And MapSuite takes care of everything else. So when it goes to render the tiles and everything, it'll convert all the coordinates, all the data in your shapefile to the proper projection so everything lines up correctly. So that's handling the first two scenarios in the sample. And we also have a couple other web methods here, one for the rotation. Again, it's very similar, except it takes in the pivot point and the angle and a few other the parameters. And you can see here where we call the update projection routine. We'll go into that. And really, again, we're just setting the feature source projection property to the new one with our new parameters. And then finally, our custom projection. It's the same type of concept where we've set those custom parameters in Proj4 and are now going to apply that to the layer as well. One last web API that we have is an information data request where you can pass in the EPSG ID number and get back some information. So you can also use the manage for projection library to get information back out if you want to display that in your UI or give your end user some information about that projection so they can tweak it or customize it accordingly. So again, this is just a real basic starter on projections. Projections can be a bit complicated at times, but we try to make it as easy as possible by giving you the APIs and libraries to do the conversion rather simply. Also, there's a great website out there called spatialreference.org. If you're not sure of what all the different projections are, you can take a look at that and compare and see the different settings so you know how to set the properties on this managed Proj4 projection class. I hope this learning sample has been helpful for you. If you have any questions at all, you can ask them on our discussion forums at ThinkGeo.com. We always monitor them and we can get really technical there and answer any specific questions you may have. Thank you.